So the title is inverses if you need to label it so you know where to find that section. Okay, so like we said, the general idea, before somebody would give you the sine and they would tell you the angle measurement, and you would give them some sort of side length. Okay? And now we're going to kind of switch up this information. What if they give you the side length? Can you find the angle measurement? So the notation is a little bit weird. You have to know if they were giving you the sine, the cosine, or the tangent, because different angle has a cosine of 1/2 than a sine of 1/2. So someone can't just say 1/2. If they say 1/2, I'm thinking probably 30s and 60s, but I don't know which one unless they tell me they were looking at the y or the x coordinate, the sine or the cosine. So the notation looks like this. I'm just going to use sine for right now. It looks like sine, like you did before, but it has the little -1 up here, which signifies it's an inverse. Okay? And that means what they're going to give you after that is not going to be an angle measurement. The number they put in here is going to be some sort of side length. And your job is going to be to tell them which angle that goes with. So they're basically asking you, like, what is the angle that has this sine, instead of the other way that they were asking it of you before. Okay? And then to make it extra confusing, I know. Okay. There's two notations. Sometimes they put the little -1, and sometimes they put the word arc in front of it. These two things mean exactly the same thing, okay? So each time you see one of those notations, you're going to try to kind of reverse your thinking a little bit and see if you can figure it out. Okay. So that means before the question would have looked like this: what's the sine of 30 degrees? And your answer would have been 1/2. Now the question would look like this. What's the sine inverse of 1/2? And your answer would be 30 degrees. So we haven't changed what anything goes with. An angle of 30 degrees still has a sine of 1/2. It's just like, which way are they going to ask me? Are they going to tell me the side length and ask me for the angle? That's when they use the inverse. So anytime a question, the last thing you do in a question is an inverse, your answer should be an angle measurement. Anytime the last thing you do is just a regular sine, cosine, or tangent, your answer should be like a length, a side length. Okay? Is this all right with everybody for the general idea of what they're doing? All right, so when you guys look at your plates right now, how many angles are there that would have sines of 1/2? So if somebody asked you this question, what's the inverse sine of 1/2? Okay, you would be thinking about all the angles on your unit circle. And first of all, there should be some red flags that go up. When you see the number 1/2, what kind of angles would you associate that with? 30s or 60s. Then you'd say you specifically want things with a sine of 1/2, meaning is 1/2 the y coordinate or the x coordinate in this case? The y. So is it the 30s or the 60s that have a 1/2 as their y coordinate? The 30s, okay? And that's how we decided this. But 30 degrees is not the only angle on your circle that has a sine of positive 1/2. What other angle has a sine of positive 1/2 on your circle? 150, right? And then you could keep going and pick some other ones. It wouldn't be 330, but it would be like 390 if you went around the circle and then extra, okay? 150 would have the same. So then the question is, how do you pick 30 and not the other ones? So they've made some rules about where we pick our angles from, okay? There's a good and a bad to that. The bad is it's one extra thing you have to know. The good is you don't have to keep listing angles forever and ever. There's only one angle that will answer their question, okay? All right, so before we start talking about how we choose exactly which one it is, we're just going to practice rewriting them, okay? So if this says the sine of y equals x, is y an angle or a side length? An angle. You take the sine, cosine, tangent of an angle, and your answer is a side length. So in this case, y is the angle and x is the side length. Okay. What's that? On that back. Is it gone? Here, Nick. No? Y is the angle and x is the side length. So we're just practicing kind of ordering things. So if we wanted to rewrite this question as an inverse question and not as a regular sine question, we would use sine inverse or arc sine, okay, because those both mean the same thing. Then you'd put something in here equals something on the other side. So remember, when you use the regular sine, cosine, or tangent, you input an angle and you output the side length. When you use the inverse, you switch it up. They tell you the side length, so the x would be here, and the answer would be the angle measurement, so the y would be here. Okay? So both of these would be ways to write this same information, okay, but with its inverse. It's kind of like when you guys would switch stuff from log style to exponent style, okay, because logs and exponents are inverses. This is the same thing, but it's sine and sine inverse, okay, instead of log and exponent. All right, so how would we rewrite part B? We've seen this one like a couple times already. So how would we rewrite part B using inverses? So it right now says the sine of 30 degrees equals 1/2. Okay. Good. So the inverse sine, so sine inverse of 1/2 equals 30 degrees. Okay, so just kind of understanding the relationship there. You're not going to have to do this explicitly. You're going to have to answer questions like this, but we want to build in your head an idea when you see it. You don't think it's just like sine. It's a little bit different, and we want to treat it properly. All right, who can tell me what C would look like if we rewrote it as an inverse? Right now it says tangent of x is equal to -4/3. So if you want to use an inverse, what's it going to have to look like? Okay, so instead of regular tangent, okay, we have inverse tangent, and then we kind of switch up what's the input and what's the output. They're not giving me an angle, they're giving me a side length, and I would tell them the angle. Okay? All right, so let's understand the rules of how we pick the answers to the questions. Okay? So for sine inverse and tangent inverse, they're actually going to follow the same rule. And then the cosine inverse is going to follow something a little bit different. Okay? And this is the reason. When you guys look at your unit circle, okay, when we picked out that 30 degrees had a sine of 1/2, you guys said that 50 degrees also had a sine of 1/2. Look at quadrant 1 and quadrant 2 on your unit circle. Okay? Look at the y coordinates. What do you notice about the y coordinates of all the points we picked out in quadrant 1 and the y coordinates of all the points we picked out in quadrant 2? They're exactly the same, okay? So those overlap. So I don't want to use quadrant 1 and quadrant 2 to answer sine inverse questions because I always have like 2 possibilities. And I just want to get one answer so we're all on the same page. So what they basically did is they said, okay, pick things on this part of the circle. Because quadrant 1 and 2 have the same sine value, so I don't really need to use quadrant 2, okay? Because 1 has all the same information in it. Quadrant 3 and 4 also have the same sine value, so I only need one of them, which is quadrant 4. Okay? So when you pick an answer to an inverse sine or an inverse tangent problem, it should be somewhere in here. And this is the way they name it. You know how this was 0, this is 90 degrees? To name it kind of fluidly, it would be weird to go, oh, you got to pick something from 0 to 90 and then something else from 270 to 360. So instead, they call this -90, and they say every time you answer an inverse sine or an inverse tangent question, okay, when you pick your angle as your final answer, pick an angle that's somewhere between -90 and +90. Okay, so -30, -45, -60, -90. Or +30, +45, +60, +90. So again, a pro and a con. You have to know this. You have to know this is where you're picking from. But there's not like infinitely many answers. Your answer has to be one of these things right over here. Okay? If you were using radians, remember that 90 is like pi over 2. So your answer would just be between -pi over 2 and +pi over 2. So the reason cosine is a little bit different is because cosine is for the x-coordinate. Do quadrant 1 and quadrant 2 have the same x-coordinate? No, almost, right? But there's positives and there's negatives, okay? So when we look at the cosine, we actually use answers between quadrant 1 and quadrant 2. Okay? Because 3 just has a repeat of quadrant 2, and 4 just has a repeat of quadrant 1, so we don't want any repeating. We want unique answers. So when you're picking an answer for cosine, you make sure that your answer, the angle that you give them for an inverse cosine problem, is between 0 and 180, okay? Or in radians between 0 and pi. Okay? So that's how we decide the inverse sine of 1/2 is 30 and not 150, because we only pick for inverse sine the angles that fall between negative 90 and 90. 150 would be too big. It's out of this, so that's why we just list 30 as the answer and not 150. Okay? All right. Does everybody have this written down? Because it's going to be important so that you pick the right one. Anybody need this slide up longer? So now we're going to try and actually answer the question. So remember, this is like what we're used to them asking. They are asking this now, but they're not going to ask it in this way. They're not going to say the cosine of what angle equals 1/2. Instead, they're going to write it like we were just talking about. They're going to ask you, what is the inverse cosine of 1/2? Okay? So, again, when you see the number 1/2, what kind of angle should pop into your head? 30s or 60s. Then you have to decide between them. Cosine is the x or the y coordinate? X. Okay? So which ones have the x coordinates as 1/2? The 30s or the 60s? The 60s. Okay? And because it's inverse cosine, remember, we want our answer, the angle that we give them, to be between 0 and 180 degrees. So which angle that's between 0 and 180 has a cosine or an x coordinate that's equal to 1/2? 60. Okay? So same information you were using on your unit circle before, but they're asking it in a different way. So we just have to kind of, it's a little bit harder to think through. Okay? So in part B to find x, they've already rewritten the problem as an inverse. It says inverse sine of 1/√2. So we're not really used to seeing these radicals in the denominator, so let's think about what that looks like if the radical wasn't in the denominator. So what they're really asking us is the inverse sine of √2/2. Okay? So when you see the number √2/2, what type of angle should pop into your head? 45s. Okay? And then remember, for inverse sine, the answer that you give them is going to be an angle, and your angle has to be between 90 and negative 90. So what angle from negative 90 up to 90, okay, in that fourth and first quadrant on the circle, has an inverse sine of √2/2, or which angle has a sine that is equal to √2/2? 45. So do you see that if you have that some sort of memorization pattern down that like 30s and 60s go with 1/2 and √3/2, and 45s go with √2/2, it's going to help you do the inverses a little bit faster because you're going to see those coordinates show up there. Okay. So for part C, it says the arctan of 0 equals x. Remember, arctan is the same thing as them saying inverse tangent. Okay. So I'm looking for an angle whose tangent is 0. Which types of positions on the unit circle have a chance at having a tangent of 0? 45s, 30s, 60s, or something different than that? Something different than that, right? Like at the corners where 0 is actually a coordinate. Okay? For the tangent to turn out to be 0, remember for the tangent you take the y divided by the x. Where does the 0 have to be in the division problem to actually get an answer of 0? In the top, right? In the numerator. If it's in the denominator, what would the answer be? Undefined. So we need 0 over whatever number that it is, okay? And remember that inverse tangent is just like inverse sine. We have to pick from negative 90 to 90. So we have to pick somewhere here. And you guys narrowed it down to one of these positions at the corners, okay? Which of these positions has a y coordinate of 0? at 0 degrees, right? This has. So this right here has 0, 1. It's at 0 degrees. Okay? If we do 0 divided by 1, would we get a tangent of 0? Yes. Okay, so the tangent is 0 at this position. Okay? So the number from negative 90 to 90 that has 0 as a tangent is 0 degrees. And that's what the value of x is. The tangents are a little bit harder because you have to think through what they would be. But every time you see a tangent of 0, it's going to be one of these corners. What about if it said a tangent of 1? What types of angles have a tangent of 1? That means the y and the x would have to be the same so that when you divided them, you got 1. 45s, right? And then what are the tangent options like for 30s and 60s? They either turn out to be root 3 over 3 or root 3. So anything that has like a rad 3 in it is a 30 or a 60. You might have to do a little arithmetic to figure out which one was the y and which one was the x. Okay? All right. The last thing you're going to see is you could see them ask you more than one at a time. Okay? But think about it. It's like order of operations. You know how you start with the parentheses, and if there's lots of parentheses, you start inside and then you like work your way outside in the problem. You're going to do the same thing here. So there's kind of two problems. We're actually going to start with part B. Okay? So there's a problem right here, and then once you figure out the answer to that, you're going to take the cosine of that. Okay? Let me ask you guys, the final answer to this problem, do you expect it to be an angle or a length? What's the last thing you're going to do? Take a regular cosine or take an inverse cosine? You're going to take an inverse at the beginning, but once you're done with the inverse, then you're going to take a regular cosine. When you're using a regular cosine, that means they're going to tell you the angle, and the answer is going to be a length. So at the end of this problem, I expect a length as my answer. If these were switched, then I would expect an angle, just to give you some perspective. Okay? All right, so let's ignore the outside part first. Okay? So inverse cosine of root 2 over 2. Remember what that's asking you. What angle on the unit circle has a cosine of root 2 over 2? So you see the number root 2 over 2, and immediately what kind of number should pop into your head? 45 degrees. Okay? Cosine is between 0 and 180, so we can actually pick 45 degrees is the angle that has a cosine of root 2 over 2. So this part is worth 45 degrees. And I haven't done this part yet. Okay? So now the question is, what is the cosine of 45 degrees? Root 2 over 2. We just kind of used that. Any idea why this one worked out to just be the number that they had originally given us? Yeah, because we have cosine and cosine inverse. Remember when we were working on the calculator? This was how we undid this. So they kind of undo each other, and you would just get this back. So if these match, that's great. If it was like sine and cosine inverse, you couldn't use that little trick. But now in the future, if you see the same function and inverse function, you can know you're just going to get what you originally had in the problem. Okay? All right, for part A, I saved this one for a reason. It's a little bit of a pain in the butt. Okay? Is 3 over 13 anything that we're familiar with from our unit circle? No. Okay, this means it's not on the unit circle, and you need to draw a picture for yourself. Okay? So, draw a triangle. The inverse sign says we have to use something here. Here the sign is positive, and here it's negative. So since it's positive, I drew my triangle above what would be like the x-axis, okay, up here. Okay? So here's the angle that they're talking about. I have no idea what the angle is. I can't figure it out because it's not one of the ones from the unit circle. But what I do know about this angle is it has a sine of 3 over 13. What positions on the triangle do the sine numbers go with? Opposite and hypotenuse. So they're telling me like this, okay? That's the most I can get from this information right here. There is nothing further I know. All I could produce for somebody is, here's a picture of your angle with this opposite and this hypotenuse. I can't tell you what the measurement is without a calculator because it's not something from the unit circle. Okay? But they don't want to know what the measurement is. They want to know what is the tangent of this angle. Can you guys figure out the tangent of this angle? So in a triangle, how do you figure out the tangent of an angle? Which side lengths do you need? Opposite over adjacent. And the opposite in this case is 3. And the adjacent is, we don't know. Can we figure it out? Yeah, using what? Pythagorean theorem. Okay, so we would do like 3 squared plus whatever this is squared equals 13 squared, and we would do some arithmetic. I don't know, 16 and 10, so 4 rad 10. All right, so 4 rad 10. I'm not allowed to leave 4 rad 10 in the denominator, so I'll multiply top and bottom by rad 10. So I'm going to get 3 rad 10 over, here's a 4, and rad 10 times rad 10 will be 10. 4 times 10 is 40. Okay. How do I know I have to draw a triangle instead of just figure it out from the unit circle? What was different about that part A than part B that I knew, oh, I'm going to have to draw this out and just kind of figure it out. I can't just know it from the unit circle. I'm asking you because when you look at a quiz or a test that has problems on it, right, how are you going to know that this one's not one you should automatically know off your head and you have to draw it, but this one is totally one that you should be familiar with? Good. Okay, just know some of the lengths on the unit circle. Every time we looked at one of these inverse problems, we saw a number and said, oh, we associate that with 30s or 60s or 45s or something like that. Was this associated with anything we knew from the unit circle? No. So when you come across that situation, you know you need to use something different, which would be to draw yourself a picture. Does that make sense to everybody? So that's going to be your big hint to do that. Okay? All right, let's try 2 more of these, and then we'll be done. And then tomorrow in class we'll practice, and we're going to have a quiz just on the inverses. Well, okay, just on the inverses. Let me say that, Lucy. On the regular ones and the inverses. So you know how last time you had a 10-question quiz? And it was all like, what's the cosine of this, the tangent of this, the cosecant of that, right? Now you're going to have another 10-question quiz. It's going to look just like it. 5 of them are going to be just like your old quiz, and 5 of them are going to be like this, okay? So you get the information today. We're going to practice tomorrow. We're going to practice on Thursday. We're going to quiz on Friday, okay? Then we're going to review next week, the whole week, everything we've done with Trig to take your test on Friday, and then let you retake the week before spring break, okay? So that you finish this all up before spring break and you can enjoy your vacation. All right, so first part right here. Remember, if there's multiple things going on, don't be scared. Just start with the innermost thing. So the arc cosine of 1/2. If you don't like the whole arc thing, remember that's the same thing as saying the cosine inverse of 1/2. So I need to figure that part out first. So remember what it's asking you. Which angle between 0 and 180 has a cosine that's equal to 1/2? So 1/2 is associated with which angles? 60s and 30s, right? Is it 30s or 60s that have the cosine that's equal to 1/2, the x coordinates? 60s, okay? So this is going to be 60. So that has figured out this part of the problem right here, okay? Which means now we need to do this. Now, what is the sine when you're at 60-degree location? Rad 3 over 2. Good. Okay. So the most complicated it's going to get is like this, where there's a combination of both of the different things that you have to do. Okay. All right, so this one starts right here, cosine of pi over 3. Are you looking, when you're doing just this part right here, are you looking for an angle or a side length? Look at what they've given you. Have they given you an angle or a side length? Is pi over 3 an angle, or is it one of your xy coordinates? It's an angle, right? Okay, it's just given to you in radian measurements instead of degrees. So this first part is like your last quiz. I'm just asking you what is the cosine at pi over 3. So pi over 3 is the same as what degrees? 60. So what is the cosine at 60 degrees? 1/2. So that takes care of that part. Now I have to do the second part of it, okay, which says what is the inverse sine of 1/2. So 1/2 either is associated with 30s or 60s. To decide which one, I look right here. It says the sine, or the y coordinate, is 1/2. Is it the 30s or the 60s that's y coordinate is equal to 1/2? the 30s. So the inverse sine of 1/2, or the angle that has a sine of 1/2, would be 30 degrees. Okay? This is why we took such a long time knowing your unit circle, because it didn't just benefit us with those first section, but it also would benefit us to know it really well to be able to get through these problems. Okay? Is this okay with anybody? Any questions on these? No? All right, so tomorrow when you guys come in, we're going to be doing a handout just on this. It's going to be our last handout that's associated with just one topic, and then you'll have a review handout. I know we've filled up your assignment sheet, but we've taken a long time to go through the trig, so we added lots of stuff in between. So tomorrow we'll practice this. Thursday we'll practice this. Friday we'll quiz just on this and the unit circle, 5 of each. Okay, so 5 like last quiz, 5 like these ones that you see here. And then next week, review of all different things. So what we did with the calculator, what we did with the unit circle, and what we did with the inverse functions before we test on Friday, and then retest the following set. Okay?